Hello friends, welcome to Learner's Planet. Friends, this is our first session for squares and square roots. In this session, we'll be discussing the basics of squares and square roots. You might have studied about integral exponent of rational numbers. So, what's a square? Suppose I have any number, maybe 3, right? So 3 raised to 2, that is actually 3 square. What's that? 3 square. Okay, we read it as 3 square. It's 5 square, it's 7 square, it's 89 square. What does it mean? 89 into 89. What does it mean? 7 into 7. What does it mean? 5 into 5, right? So we call it as 5 square, 7 square, 89 square. Maybe this 3 by 4 square. That means 3 by 4 into 3 by 4. Okay? So let's discuss the topic in detail. Now let's write the squares of first 10, 15 natural numbers. 1 square, that means 1 into 1, that's 1. 2 square, that is 2 into 2, that is 4. 3 square, that means 3 into 3, that's 9. 4 square is 4 into 4, 16. 5 square is 5 into 5, that is 25. 6 square is 6 into 6, that is 36. 7 square is 7 into 7, that is 49. 8 square is 8 into 8, that is 64. 9 square is 9 into 9, that is 81. 10 square is 10 into 10, that is 100. 11 square is 11 into 11, that is 121. Similarly, you can find out the squares of other numbers as well. 15 square is 15 into 15, 225. Now one important thing over here is 2 square is 4, right? Just listen to me carefully. 2 square is 4. That means square root of 4 is 2, right? 2 square is 4. Square root of 2 is square root of 4 is 2. Similarly, 3 square is 9 and square root of 9 is 3. Okay, just listen to me carefully. Square and square root. 4 square is 16 and square root of 16 is 4. 5 square is 25. Square root of 25 is 5. Similarly, 15 square is 25 and 25 square root is 15. Okay, so square and square root, two important terms. I hope you are clear. Now the next term is perfect squares. Now what's a perfect square? Suppose we have any natural number, maybe n, right? And square of that will be what? M square, right? Okay, that will be some other natural number. As we have 3, square of 3 is 9, right? Square of 5 is 25, right? Square of 7 is 49. Now here 9, 25, 49. Okay, all of these numbers are what? Perfect square. Why? Because we have a natural number whose square is 9. We have a natural number whose square is 25. We have a natural number 7 whose square is 49, right? So a number or a natural number which can be written as square of an other natural number, that will be a perfect square, right? Similarly, 121 is what? 11 square, right? That means 121 can be written as square of some other natural number, right? So we call them as perfect square numbers. Okay, we can take some examples, maybe 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, right? 225 and more, right? Square root of 4 is what? 2. 2 square is 4. Square root of 4 is 2. That means 4 is a perfect square number, right? Because its square root is a natural number. You have to be very careful. Square root of 9 is 3. So that's a natural number. That means 9 is a perfect square number. Square root of 16 is 4. That is a natural number. That means 16 is a perfect square number. Similarly, square root of 64 is what? 8. That is a natural number. That means 64 is a perfect square. Okay, so this way you can check whether the given number is a perfect square or not, right? As 169, square root of 169 is what? 13. That is a natural number. That means 169 is a perfect square. Okay. Now friends, let's discuss how do we find that whether a given number is a perfect square or not. Suppose I have a number maybe 225, right? So what is the first step? You go for the prime factorization of the given number. Now 225 is what? If we factorize it, just show you over here. It's divisible by 3, 5, 6, 7, 8, 9. So it's divisible by 3. So 3, 7 is at 21 and this, right? Then 3, 25, 5, 5, 5, 1. So 225 can be written as 3 into 3 into 5 into 5, right? Now we have 3 in two numbers, we have 5 in two numbers. That means we can group as 3 into 3 into 5 into 5. Now just listen to me carefully. When we group the 3's and the 5's, what is happening over here? All the 3's are coming over here, all the 5's are coming over here. Now we have even number of 3's and even number of 5's, right? Even number of 3's and even number of 5's. Listen to me carefully. Even number of 3's and even number of 5's. And we don't have any extra number over here. That means what? This given number can be factorized this way, and if it can be factorized this way, it will be a perfect square number, right? That means if it is factorized like this, if we are having even number of factors like 3, if 2 times is there, maybe 3 is 4 times, then that number will be a perfect square, right? And we should not have any extra factor, okay, which cannot be grouped into even number. Okay, suppose I have a number 45, right? Now I factorize 45. So is 3, 15, 3, 5, 5, 1. That means it is 3 into 3 into 5. Now if we make group of the same numbers, now what is happening over here? We are having 3 for 2 times, but we don't have 5 for 2 times, right? That means what? It cannot be grouped in even numbers, right? That means 45 is not a perfect square. Okay. Similarly, we can take other examples also. Now suppose I have a number 640. Okay, what is the first step? I'll factorize it to 320 to 160 to 80 to 40 to 20 to 10 to 5 and 5, 1, right? Now I just write all the factors over here. 2 into 2 into 2 into 2 into 2 into 2, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7 and then 5. Now if you make group like this, make group of 2, 2. Okay, now we are left with 1, 2 and 1, 5, right? So it is not a perfect square number. That means 640 is not a perfect square number. If we had one more 2 and one more 5, then only it would have been a perfect square number. Okay, let's take more examples. Now let's take this number 17640. Now let's check whether this is a perfect square or not. So first of all, we'll be doing prime factorization. It's 2 8s are 16, 8s are 16, and then 2 0, 2 4 4 1 0, 2 2 2 0 5, Now it's not divisible by 2. Let's take 3 now. 3, that means 5, 6, 7, 8, 9. That means this number is divisible by 3. So 3 sevens are 21, 1 and 0. 3 threes are 9, 1 and 5, 15. Okay. Further, let's see whether it is divisible by 3 or not. So 7 and 3, 10 and 5, 15. So yeah, it's divisible by 3. So 3 twos are 6, 1, 3 fours are 12, 1 and 3 fives are 15. Okay. Now it is not divisible by 3. So now let's divide by 5. 5 fours are 20, 4 and 5, 45, 5 nines are 45. Now this 7 sevens are 49 and 7 1 is 7. So we got the factors of this as 2 into 2 into 2 into 3 into 3 into 5 into 7 into 7. Now make group of 2 2. Now we are left with 1 2 and 1 5. Okay, that means this number is not a perfect square. So the next question arises, if you wish to make this number as a perfect square, what you can do? Either you divide it by 10. So if you divide it by 10, the entire number, then the all numbers will be converted into group of 2 2. Okay, so either you divide by 10 or you multiply by 2, one more 2 and one more 5, right? So either divide by 10. Okay, so 2 and 5 will be eliminated, or multiply by 10. Okay, so we'll be getting one more 2 and one more 5, then we'll be getting one more set of 2 and one more set of 5. So this number will be converted to perfect square number. Okay, I hope you are clear. Now let's check some more numbers whether they are perfect squares or not. Suppose here I am having 576, right? So what is the first step? Divide it by 2. 2 twos are 4, 1, 2 eights are 16, 1 and 2 eights are 16. Okay. Then further 2, 1, 4 and 4. Then 2, 7, 2, 2, 36. Then 2, 18, 2, 9, 3, 3 and 3, 1. Now we have one pair of 3, one pair of 2, one pair of 2, one pair of 2. That means we have even number of pairs of every number, right? So what is happening over here? It's 2, 2, 2, 3, right? That means 576 is a perfect square number, right? We are not left with any number over here. Okay. Now next is, suppose I have 2500. 2, so it's 1 2 5 0, then 2 6 are 12, 2 2s are 4, 2 5s are 10, then it's not divisible by 2. Let's take 5. So 5 1 is 5, 1 5 2s are 10, 5 5s are 25. Now this 5 25, 5 5 5 1. Okay, so one pair of 5, one pair of 5 and one pair of 2. So we are not left with any number extra over here. That means 2500 is also a perfect square number. Okay. Now friends, we move one step ahead. Let's check some more numbers, whether they are perfect square or not, and let's find out their square root also. Okay, so it's 1156 I am having. First of all, let's divide it by 2. 2 5s are 10, 1, 2 7s are 14, 1, 2 8s are 16. Now further 2 2s are 4, 1, 7, 2 8s are 16, 1, 2 9s are 18. Now 289 is not divisible by 3, 4, 5, 6, 7. You must be knowing the divisibility rule of basic numbers. 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? Up to here you must be knowing the divisibility rule. Now this is an odd number, so definitely 2, 4, 6, 8, 10, 12, 14 and 16, it will not be divisible. Now 8 plus 9 is 17 and 2 19. That means this number is not multiple of even 3. So even 3, 9 is eliminated, right? Now let's check by 7. 7 fours are 28 and 7 1 is 7 and 2 is remainder. That means this number is not even divisible by 7. Let's check it by 11. So what is the divisibility rule of 11? Add the alternate number, that means 9 into 11, and subtract this. So 11 minus 8, we are left with 3. That means we are not having 0 or 11. That means this number is not multiple of even 11, right? Check it by 13. The same rule can be applied over here, or you can directly divide it. 13 twos are 26, 2 and 9. So we are having 3 as remainder. That means this number is even not multiple of 13. Now let's see by 17. So 17, 1 is 17. We are left with 11, 11 and 9, 17 sevens are. That means this number is actually 17 into 17. So 17, I divided by 17, 17 1 is 17, 11, 17 sevens are 119. Right? Now we are having one pair of 17 and one pair of 2. That means this number is a perfect square number. Now what will be the square root of this number? See, out of every pair of number you take out 1. We have one pair of 2, I take out 2. One pair of 17, I take out 117. Right? So square root of this number will be what? 2 into 17, that's 34. Okay? Or we can say 1156 is square of 34. Okay? 34 square is 1156, or square root sign is this. Square root of 156 is 34. Okay, so you should be knowing both the ways. Square of 34 is 1156 and square root of 1156 34. And how do we find out the square root? That I have shown over here. Okay, I hope you are clear. Now I have number 2025. So let's divide it by 5, 6, 7, 8, 9. That means this number is multiple of 3. So let's divide it by 3. So 3, 6 are 18, 2, 2, 3 sevens are 21, 1, 3 fives are 15. Further, let's see. 6 and 7, 13 plus 5, 18. That means still it is divisible by 3. So 3 twos are 6, 3 twos are 6, and 3 fives are 15. 5, 6, 7, 8, 9. Further, it is divisible by 3. 3 sevens are 21, 3 fives are 15. Further, 325, then 5, 5, 5, 1. Okay, let's make pair 3, 3 and 5. So we are not left with any number extra apart from these pairs. So definitely 2025 is a perfect square number, and out of every pair we are taking one number out, one number out, one number out. Now 3 into 3 into 5. So 5 threes are 15, 15 threes are 45. That means square root of 2025 is 45, or we can say 45 square is 2025, or square root of 2025 is 45. Okay, so if you multiply 45 by 45, you'll be getting 2025. Okay, so the whole story should be clear in your mind, right? What is square and what is square root, and how do we find out the square root? Okay, so this is very simple. Just take out one number from each pair. 2 threes are there, or a pair of threes there, we take out 1. Pair of threes there, where we take out 1. Pair of 5, we take out 5, 1, 5. Okay, so 3 into 3 into 5, 45 is the square root of 2025. Okay, now suppose I have number 4, 7, 6, 1. Right, I have to find out whether it's perfect square or not. Then if it is a perfect square, I have to find out the square root of the number. Now 4 plus 7 is 11, 12 and 6, 18. That means this number is divisible by 3. So let's divide. 3 ones are 3, then 1, 3, 6, 3 fives are 15, 2, 3 eights are 24, 2 and 3 sevens are 21. Okay. Now 5 and 1 6 and 8 14 plus 7 21. So further it is divisible by 3. So 3 5s are 15, 3 2s are 6, 2 3 9s are 27. Now this number is not divisible by 3 and 529 is actually divisible by 23. So 23 into 23 is 529 and then 23 23. I'm sorry, this is 1. Okay, so out of this is a perfect square number because we are not left with any number extra. Out of this pair we take one number, out of this pair we take one number. So 3 into 23, that is 69. That means square root of 4761 is 69, or we can say 69 square is 4761, or 4761 square root is 69. Okay, I hope you are clear now. Now, let's take this question. Find the smallest number by which the given number must be multiplied so that the product is a perfect square. Now friends, first of all, what we have to do, we have to check whether the given number is a perfect square or not. Then we'll see what happens. So 2, 3, 8, 0, 5. First of all, we have to go for the prime factorization. 3 and 2 5 and 5 10 and 8 18. That means this number is divisible by 3. So let's divide it by 3. 3 7s are 21, 2 8 3 9s are 27, 1 0 3 3s are 9, 1 3 5s are 15. Okay, now let's see. 7 plus 9, 16, 17, 18, 19 and 5 24. That means this number is still divisible by 3. So let's divide. 3 2s are 6, 1 3 6 are 18, 1 3 4s are 12, 1 and 3 5s are 15. Further, let's check. 6 and 2 8 plus 4 12 and 5 17. It's divided by 3 5. 5 5s are 25, 1 4, 5 2s are 10, 4 5 9s are 45. Now 529 is actually 23 into 23. So it's 23, 23, 1. Now let's make the pairs 3, 3, 23, 23 and we are left with 5. That means this given number 23805 is not a perfect square. Is not perfect square. Now what is the smallest number by which it has to be multiplied so the product is perfect square? Now we are having a single 5 left with us. Now we want one more 5. If we have one more 5, then we can make a pair of 5 also, right? So that means the least number this that should be multiplied to this number is 5. Okay, so it's 3 into 3 into 5 into 23 into 23. So if we have one more 5, this number will be converted to perfect square number. Okay, so your answer is 5. Okay, now let's do this problem. First of all, prime factorization. 5 6 7 8 9. That means this number is divisible by first of all, it's even number, so it's divisible by even 2. So 2 6 are 12, 0 2 7s are 14 and 1 0 2 5s are 10. Now divided by 3. 3 2 0 3 2s are 6, 1 3 5s are 15. Further 3 3 6 are 18, 2 3 7s are 21, 1 5. Then further 3 2s are 6, 2s are 6, 5s are 15. Further 3, okay. Now 5 5 1. Now let's make pairs. So we are left with 1 2 and 1 3, right? So definitely it's not a perfect square number. So to make it a perfect square number, what we need? We need 1 2 and 1 3, right? 1 2, if we have one more 2, then we'll be getting a pair of 2. If we have one more 3, then we'll be getting a pair of 3, right? So what we want? One more 2 and one more 3. Okay, so 2 into 3 is what? 6. So if we multiply this number by 6, that means 12150 into 6 if we do, then it will be a perfect square number. Okay, getting me? Because we'll be having one more 2 over here and one more 3 over here. So we'll be getting a pair of 2 and a pair of 3. Okay, so in that case, the number will be converted to perfect square number. Or if you are asked like by what number it should be divided, then what you can do is you can eliminate this 2 and you can eliminate this 3. Now if you how do we eliminate? We can divide this expression by 6, right? So if 12150 is divided by 6, whatever the number you will be getting, that will be also a perfect square number, because in that case this 2 and this 3 which are left extra over here, that will not be there. Okay, so 12150 should be multiplied by 6 to make a perfect square number, or 12150 should be divided by 6 to get a perfect square number. Okay, I hope you are clear. Friends, I hope you might have enjoyed this session. We'll be taking more concepts and more problems based on squares and square roots in our next session. Do revise this session before you come to the next session. Okay, bye-bye.